This is Unit 7, Section 7 Notes, Solving Advanced Exponential Equations. I say advanced, in my opinion, I don't really think they're too advanced, but they are different than what we've been doing. And this is the only thing we're learning today. So let's get to it. So I just need to solve each exponential equation using logarithms. If it loads, the paper you have, just using logarithms, that's it. Okay. So, to solve these, you first need to identify your base. So let's look at number 1 just to start. So identify my base is 8. So my first step for all of these questions is I have to get the base by itself. Okay, I cannot change the exponent yet, so you cannot don't touch the exponent. I need to get rid of any numbers before the base or any numbers after the base that are not part of the exponent and move it to the other side. If I look at number 1, I have my 8 as my base. My exponent is fine, and I have no numbers before or after the 8. Everything is already on the other side, 92. So once I have my base the same, I convert. So I want I want log base b of a equals x. So if we label these, I have b, here's x, and here's a. So once you get the base by itself, you convert to a log. So now, like the last lesson we did, we converted from a log to exponential. Now we're converting from exponential to log. We're just going backwards. So when I write this, no, go away. I'm going to write log base 8, my a is 92, equals m minus 7. Okay, now, see, look, now I can solve for m because m is not in the exponent anymore. Okay, so from here, I just need to add 7 to both sides, and then I'm done, right? Now, here's the catch, and this is a big thing that I saw people do with the radicals we did, is notice how I have my log 8 of 92 and my 92 is in parentheses. Whenever I move a number to the other side, whether I'm adding, subtracting, multiplying, dividing, whatever it is, I cannot change the number inside the parentheses. That number has to stay the same. Unless I have another log, which I do not, I cannot change the number. Okay? So when I do this, I'm actually going to have my answer right away. I would have log 8 of 92, and then I added 7, so I have to put it behind the parentheses. I cannot put it inside. Equals m. And that's how I want my answer. I'm just going to leave it like that. Because anybody can type this in the calculator. I don't care if you can do that. I care that you can get to this point, because if you can get to this point, then you can definitely get the answer with a calculator. That's too easy. I don't want a decimal. I don't want a fraction. I want this. I want a log answer. Okay? That's why it says using logarithms. My answer should be in a log form. All right, let's look at number 2. So identify the base. Base is, base is 4, right? So here's my base. My exponent is x plus 1. So those two I have to leave alone. I need everything else around that to go away to the other side. So this 7, let's subtract 7. Got to move that first. That gives me negative 4, x plus 1. And then 18 minus 7 is 11. Okay. Now, you're probably thinking, hey, wait, how come the negative stayed? Well, I only moved the 7, right? I didn't move the negative, so I got to keep it. But now I still want the negative gone, so I would divide by negative 1. So 2 negatives on this side would make those positive. That's how I make it a positive 4. So I want 4, x plus 1 equals 11 divided by negative 1 is just negative 11. Okay, I have the base alone. Now I can convert it. Okay, so I have my base, I have my x, I have my a, and I want log base a equals x. Okay? So I have log, base is 4, my a is negative 11, and it equals x plus 1. But wait a minute, didn't you say you can't have a negative log? Very true, I cannot. So, because this number is negative and is now part of the log, I can stop everything I'm doing and just write no solution. Because negative logs do not exist. Right? So anytime you do this and you convert and your base or your number inside the log is negative, you can stop and just write no solution, move on to the next question. I can't do anything else for this question. That's it. There is no answer. Alright, last one. This one I included every possible step you could see on any of these questions. That way you can see everything going on. Now, you don't always have everything going on, but this includes everything, so you can at least see all the steps that you could take. So, first off, identify the base. Okay, my base is 16. My exponent is 7y plus 2. That means I need to get rid of that 6 and the minus 2. So just like solving for any other variable, like an x or something, I have to add or subtract before I can multiply or divide. It's like the opposite of PEMDAS, right? So I move the 2. That gives me 6 times 18, 7y plus 2 equals 82 plus 2 is 84. Okay, I still need that 18 by itself, so I'm going to now divide by 6 because this is multiplying by 6, right? That gives me 18, 7y plus 2 equals 84 divided by 6 is 12. Okay, I have my base by itself. So here's base, here's x, here's a, and I want log base of a equals x. Okay, whoa. So let's rewrite this in log form. So I have log base is 18 of 12 equals my exponent, which is 7y plus 2. Now I can solve for y. So just like everything else, to solve for y, I first move this 2. So I subtract 2. Remember though, I cannot change the parentheses, so I just have log 18 of 12, and then minus 2 is outside the parentheses, equals 7y. And this is why I say you don't need to write parentheses on the log, but if you always use parentheses, to me it helps to not accidentally make a mistake. Because without parentheses, you might accidentally put those together. You might do 12 minus 2 and put log 18 of 10. You don't want to accidentally do that. So if you always use parentheses, that should help remind you that, oh, I got to leave that alone, and this goes outside that. Okay? That's the only reason I do that. If it helps, it helps. If you don't need to do that, don't worry about it. Just saying, if you always put it there, it's kind of like a constant reminder. Alright, I need y, so because it's 7 times y, I would divide by 7. And again, I cannot change the log, I can't change the base, I can't change the number in parentheses, I can't change the number outside, I can't do anything. So my answer is literally that whole fraction. So I would write log 18 of 12 minus 2 all over 7 equals y. That is my final answer. Okay? And again, I want it in log form. I don't care about the decimal. The decimal means nothing to me. The decimal shows me that you can type it into a calculator or you can scan it with your phone. And that doesn't get you anywhere. So, solve for log and leave it in log form. And that is it for today's lesson.